Welcome to A2 Physics. In your first year, you mastered objects moving in straight lines and parabolas, but the physical world is much more complex. From planets orbiting stars to charged particles deflecting in magnetic fields, the universe moves in circles. The core paradox you will explore in this unit is that an object can travel at a steady speed, yet be continuously accelerating. Because velocity is a vector, changing direction means changing velocity. You must separate the geometry of the motion from the physical forces causing it. This unit is the gateway to the rest of the syllabus. Master it, and the hardest mechanics marks become yours.
We begin by abandoning the arbitrary 360 degrees you grew up with. To link rotational motion to physical distance, we need a mathematically rigorous measure. When an object moves along an arc exactly equal in length to the radius of its circle, the angle it sweeps out is exactly 1 radian. This single geometric shift is the key that unlocks every equation in rotational physics.
Once we measure the angle, we must quantify how fast it changes. Enter angular velocity, represented by the Greek letter omega. You will learn to calculate this rate of rotation and connect it to the time period and frequency of the motion. Most importantly, you will use the equation V equals R omega to bridge the gap between the invisible spinning angle and the actual linear speed of the object rushing through space.
If an object's speed is constant but its direction is changing, what is its acceleration? The examiner will frequently ask you to explain this. You must clearly state that a continuous change in velocity requires a continuous acceleration, directed exactly towards the center of the circle. You will calculate its magnitude using 2 interconnected formulae, and you will prove mathematically why this central acceleration does absolutely zero work, leaving the kinetic energy unchanged.
Finally, we reach the dynamics. Acceleration requires a resultant force, but here is the ultimate exam trap. Centripetal force is not a new, fundamental force like gravity. It is simply the label we give to the resultant physical force pulling an object into a circular path. Whether it is the tension in a swinging pendulum, the friction on a car's tires, or the normal contact force on a banked track, you will draw force diagrams, resolve the vectors, and equate the central component to mass times acceleration.
By the end of this unit, you will be able to convert fluently between degrees and radians, calculate angular velocity, prove why circular motion requires continuous central acceleration, and resolve physical forces to find the centripetal resultant force.